Hey guys, welcome back. Today we're going to be doing question number 70 from Leet code. It's called climbing stairs. One of my absolute favorite questions here in this website. Um, the prompt goes as following: you are climbing a staircase. It takes n steps to reach the top. You can each time you can either climb one or two steps. In how many distinct ways can you climb to the top? Um, the question gives us two examples. So in a staircase with two steps, you can go one at a time or climb both steps in one go. In a staircase with three steps, you can climb 1, 1, 1, climb 1, 2, or 2, 1. Okay. What about four steps? I have a little drawing here to help you guys visualize this. So once again, let's look at three steps. For three steps, as they described previously, could go 1, 1, 1. That's one way. You could go 1, 2, or you could go 2, 1. Three different ways. Okay. What about four steps? Well, you can still go one at a time. 1, 1, 1, 1. That's way number one. You could go 2 and 2. That's way number two. You could go 1, 1, 2. That's way number three. You could go 1, 2, 1. That's way number four. Or you could go 2, 1, 1. That's way number five. Okay. So for four steps, there are five different ways. For three steps, there are three different ways. For two steps, there are two different ways, as it's described in here. So I created this little Excel sheet so we can visualize this better. In this column, I have the number of steps, of stairs. In this column, I have the different ways. I already filled this in. We discovered that four steps takes us five. In four stairs, there are five different ways. Sorry. What about five? Um, Before we continue, let's look at the pattern here. There are not a lot of numbers here, but if we look closely, we can see that for four steps, the answer is the addition of the previous two steps. So if this trend continues, for five steps, it should be 3 plus 5, which is 8. Okay? And you've probably seen this before in a math class or maybe in a computer science class. But the addition of the two previous numbers is what's called Fibonacci numbers. Okay? If you do a quick Google search, here are the numbers. So it starts with 0, 1, and 1. And so 1 plus 1 is equal to 2. 1 plus 2 is equal to 3. 2 plus 3 is equal to 5. 5 plus 3 is equal to 8, and so on and so forth. Really interesting sequence. I encourage you guys to, if you haven't seen it before, look at it, because there are different things even in nature that follow this Fibonacci number sequence. Okay, so coming back here, if you want to solve this in Excel, there's a quick little way to do it, which is the sum of the previous. Oops, not what I wanted. Sum of previous both numbers. So for 6, it would be b5 plus b4, which gives us 13. Okay. And if I scroll this down, it'll continue. Let's do it till 10, for example. Boom, boom. Okay, here we go. So what they're doing is simply adding previous two numbers and giving us the answer. So for 10 steps, there are 89 different ways, which is incredible. This number gets exponentially uh, huge in every iteration. So here I'm going to go through the code that I've written beforehand, and I'm going to walk this through with you guys. Um, let's say there are 5 different steps, okay? And here I'm just calling my method and printing it in my console, okay? Um, so I'm going to start up with 2 base cases, which is something that it's going to help us out because uh, here I start with int I is equal to 3, which is uh, where the question actually basically starts, right? Um, if n is equal to 1, he's going to return, the program is just going to return 1. If n is equal to 2, it's going to return 2 because there's one way to climb a stair with one staircase. There's 2 ways to climb a stair with 2 steps. What about 3, 4, or 5, right? I created 3 different variables to keep track, current, previous 1, and previous 2. And I created a for loop that iterates from 3 to whatever number this is, whatever number of steps it is. So in this case, it's 5, so it's going to iterate from 3 to 5, which is this part here. I is equal to 3 and n is equal to 5. Let's go through what current, previous 2, and previous 1 is. So every time it iterates, current 1 is the addition of the previous 2 numbers, which is basically the Fibonacci sequence, but we also need to change the value of previous 2 and previous 1, otherwise the code just doesn't work. It needs to continue giving, it needs to continue refreshing what the previous 2 numbers are in order for this to work, right? So after giving current a new number, I give previous 2 a new number, which is whatever previous 1 is, and then previous 1 is going to be current. So let's go through an example here. Let's say that n is equal to 5, and let's say we go inside this for loop. So current is going to be equal to previous 1 plus previous 2, which is going to be equal to 3, and then previous 2 is going to be equal to previous 1, which previous 1 is equal to 2, we can see over here, so we can switch this to 2, and then previous 1 is going to be equal to current, so current now is equal to 3, so I'm going to write 3 here. And then we're going to iterate through it again because I is going to be added by 1, so I is now 4, and it's going to loop till 5. Current is going to be equal to 3 plus 2, which is 5. Previous 2 is going to be equal to previous 1, which is 3 right now. And then previous 1 is going to be equal to current, which right now is 3. One more loop because 5 is less than or equal to 5. 5 is equal to 5. So now current is equal to 8. Previous 2 is going to be equal to 5. And previous 1 is going to be equal to 8 as well. And now I is equal to 6. This is no longer true. I is no longer less than n. So we leave the for loop and just return current, which is right now equal to 8. So if I run this, should give me I is equal to 8. Okay. Let's try I is equal to 7. Sorry, n is equal to 7. Let's run this. I'll give this 21. If we look at our Excel sheet, it is a fact that n is equal to 21. What about 10? Let's see if it's equal to 89. Okay. Then save it, run, Java application, 89. So it's working. Um, so current is being current previous one and previous two are being changed every single time it iterates. Current is the addition of previous one and previous two, and then of course we need to change the previous two numbers because every single time we're moving one number closer to what the current is. Let's copy this and throw it in Leet code, see if it works, which it should. Leet code. Let's submit this. Great, it works. Accepted. That's what we wanted. It's working. Perfect. Thanks for watching. Let me know if you guys have any questions. I think that it was well explained with the Excel uh, and the drawing. Um, yeah, thanks for watching. Consider subscribing and have a good day. Thanks, guys.